All yours.
Thanks, Gladys. Hey, everybody. So my name's Caleb Funk, and I'm one of the team managers here with IMAGINiT. And if you've been on any of these webcasts with IMAGINiT, you know that I do a lot of them. So I've been with IMAGINiT for about 19 years now, and I focus mainly on the data management products and working with the manufacturing products, which is what we're taking a look at today. So it's been kind of interesting. Inventor has, as it's gone on, as it's changed, it's done all these things. There's so many different tools. I always say I remember when I started and there was literally AutoCAD, and that was the tool, and then Mechanical Desktop came along. And if you were to look at the product design suite today, it is massive, and there's tons of tools. So what we've done internally is we've started to specialize a little bit. There was once upon a time everybody knew every single tool, and now there's enough of them that we're beginning to specialize. We've got different people working with certain tools more than others, and Walt is one of our applications experts, and he's been tasked with working with Inventor Nesting. He started working with it since it came out with 2019 and working with it all along. So Walt, I'd have you introduce yourself just a little bit, and then I'll just have a few more things about IMAGINiT.
All right, good morning, everybody. I'm Walt Jaquith. It is at least morning where I'm at here, just south of Portland, Oregon. And I've been with IMAGINiT Technologies for about 7 years now, and before that I was a mechanical designer, and before that I was a grease monkey. I was a mechanic and a fabricator and a sheet metal guy, and so I kind of came up that way into this kind of work. Been with Inventor. I was kind of chuckling because I was looking through my closet the other day and I found a T-shirt that they gave me that has the original Inventor logo on it when I attended an event where they unveiled the beta of R1. So I've been with Inventor since the very beginning and took an early look at nesting when it came out about a year ago now, and have been playing with it since, and been through a few adventures that way. But that's a little bit about me. Caleb, back to you then.
Okay. So I'm going to talk just a little bit about IMAGINiT and who we are. So IMAGINIT's it's a RAND Worldwide company. RAND Worldwide is the parent company, and there's 3 different divisions within there. IMAGINIT's probably the largest division. So we work with the Autodesk products as well as some scanning tools like Geosystems, and we really focus on the software for Autodesk and then professional services and training going around that. We also have a RAND 3D. It's another division, and it's a provider of Dassault software solutions and Dassault and PTC training. And then if you've ever taken a class with IMAGINiT, heck, if you've taken a class with just about anybody on AutoCAD, you probably used Ascent courseware when you did it. It was the book that came with it, all the training files, all of those sorts of things. So Ascent is our sister company, and it's really nice to be able to work with people who literally wrote the book on some of this stuff. So IMAGINiT is, we're pretty large. We've got offices all across North America, up there into the provinces in Canada, and we've recently merged with ASI. We've brought their team alongside ours, which expanded our reach as well, and that's what the blue ones are all about. So we've got this wide range geographically. One of my favorite things about seeing all those different offices is how much that gives us in terms of technical depth. So many of those places, they're going to be represent not just sales, but tech people as well, and that's where we get these presentations like we have today. So Inventor Nesting, just to make sure we're all on the same page, kind of like in college when they said, hey, if you're in the room for this, you're in the wrong room. I want to make sure everybody's in the right room. So Inventor Nesting, what we're looking at, this is a tool that's embedded into CAD, and it's true shape nesting software. The whole idea, of course, is to be able to optimize your yield from the raw material. So this is only part of the production and design and manufacturing collection. I mentioned that collection, all these different tools, this is one of them. So you can't purchase nesting as a separate product. It's part of the collection. What we're looking at is automated true shape nesting, so we're able to lay this out, optimize it, and find this information. It is integrated directly into Inventor. Matter of fact, we'll see a lot of that today. And the idea is we can have this smooth workflow for creating cutting paths right off of those. So that's enough PowerPoint from me. I am going to turn it over to Walt. So Gladys, if you could go ahead and make Walt the presenter and he can share his screen. I'm going to stay here in the background, and I'll be looking out for any Q&As and things like that. and I'll probably chime in from time to time. I usually can't help myself from talking on one of these things. So it looks like we're switching over to Walt to be the presenter. And then Walt, go ahead and share your screen whenever you're ready.
All right, I'm going to share my screen, pull up Inventor. Everybody should be able to see that. Okay, so I'll start off by saying it's been a bit of an adventure preparing for this particular screencast because, as you know, Inventor 2020 just came out, and I had not planned on using 2020, but as Caleb mentioned, the nesting utility comes packaged only with the collection, and as resellers, we don't get collections; we get individual pieces of software. So the licensing for nesting for us is a kind of a special deal that they do, and there's a timer on it. And so just about the time I was getting ready to prep for this particular release, my license of 2019 glitched. And at the moment, I can't get into it. So that forced me over to 2020. This is Inventor 2020, and the nesting is working. However, in 2020, there is a bug, and I'm not going to be able to avoid it. And so not necessarily a bad thing that we went this way, because some of you are going to be moving to 2020 now, and Autodesk has been made aware of this. I've been in communication with them, so they're on it. I'm expecting a hot fix. But at the moment, I'm going to have to show you a few things and the bug and a workaround for it. So I'm going to work that into my presentation. But we're going to look at nesting. Right now, I've got this model open. This is a CNC burn table that is designed to be bolted together out of mostly formed sheet and plate. There is a whole bunch of 8-gauge plate in here. There's also some 1/8-inch steel plate, and just a few pieces. These bottom pieces here are 3/8. And so I'm going to use this as my first guinea pig for this and talk about setting up a model for export into nesting. Now, one of the things about this, these parts, if I open them, go ahead and open one of these guys up. It is a sheet metal part. It does have a flat pattern. And so this is one of the things that the nesting tool will look for if I import an assembly in. It will look for the parts that are sheet metal and have flat patterns. And one of the things about setting up your model to do nesting is that however the flat pattern presents in Inventor is the way that it will come into the nesting utility. So, you know, I've got this thing, it's kind of laying on its side here. Is that the way that I want it? If it isn't, one of the things I might do here is come over here and edit the flat pattern definition, and I could define a new, you know, horizontal, you know, align horizontal with this edge, for instance. Okay, if I want it to come in that way, I'm going to cancel that. Actually, I need to put it back or undo it. But for your sheet metal parts, you want to make sure that they have a flat pattern, and you want to make sure that the flat pattern is oriented correctly, the way that you want it to come into the nesting utility. That's one of the things that Inventor Nesting will look for. In recent releases, there were several point releases of version 2019, and in the recent releases, they expanded the options for bringing different parts in. And the original release, you could only bring in sheet metal parts or DXFs. And they expanded it in that you can now bring in other Inventor parts, and they added some functionality there. Unfortunately, that's the part of the software that is experiencing the glitch. And, well, almost part of it anyway. So we'll talk about that. But I've got this part. Of course, it's got other parts that are not sheet metal in it. And we'll talk about the way the nesting utility handles those as well. So I'm going to start off with this guy as the guinea pig, and I'm going to come up here and go New. The nesting utility adds a new type of file format, INEST, I-N-E-S-T. And just similar to the presentation files, all the nesting is handled in a separate file. And I'm going to go ahead and pick a standard iNest template and say create. And it's going to open up a blank iNest file. Now, a couple things about this. If you open this up, the Manage tab in the Nesting tab, Manage panel, has a process material library. It has options. This provider's in the stock is down in a flyout. I found that I'm into this quite a bit, so I put it up. You know, you right-click on this guy, and I can move it back to the expanded panel if I want to. I put it up in the main panel because, especially with the bug we're going to see in a minute, in my experience, the workflow, you're going to want to look at this. I'm going to click on this. Now, this lists the 4 types of files that you can bring in: a DWG file, a DXF file, an IAM Inventor assembly, and an IPT. These 4, there's nothing to do here. I can't even uncheck these. They're checked by default. The IPT has several options in it: Inventor Sheet Metal, Composite Part, Inventor Part, and Generic CAD. One of the things that you can do with this is using the AnyCAD functionality Inventor. I can bring in any part, a SolidWorks part, a Rhino part, anything like that, and I can use it in the nesting program, and that's what these are for. What I'm going to do right at the moment is I'm going to uncheck these 3 and filter them out so that in the IPT format, Inventor's only going to look at sheet metal parts. Now, I'll expand these back out later and show you what to do with those, but for the purposes of that, of our CNC burn table, I want the sheet metal parts and nothing else. So I'm going to say OK there. The next button to look at before we start is the process material library. Now, in here, I have created several materials before we even start. I've got 8-gauge steel in here at thickness 164. I've got 6061 aluminum and 10-gauge steel, 3/16, 3/8, and 8-inch steel. The idea behind this is that Inventor will look at the material and the thickness, mild steel, steel mild, and 0.135. And as long as it finds a match, it will map this material in the nesting utility to the material in Inventor. So if I kick out of this for a minute and go back to this part here, go to my sheet metal defaults, I've got a sheet metal rule for 8-gauge steel. Its material is steel mild. Its thickness is 0.164. And so when I import this into the nesting utility, it should find those 2. They have to be exactly the same. Going back over here, into nesting again and into the material library. And there it is, 8-gauge steel, steel mild, 0.164. This is where the bug is. It is not going to map that material in Inventor into the nesting utility, and so it's going to offer to create a new one. But let me talk about these for just a minute because I do expect Autodesk to get this working fairly quickly. And so there's a couple different ways that I can create materials in here. I can simply add one. Comes in with material ID. I can set the material. I can set a thickness. And if I want to, I can tie it in with the provider. In this case, Inventor is my only option, the way I'm set up at the moment. But I can come over here and say, okay, this is steel mild. Got everything in the world in there. Okay. And tie that to Inventor. That's optional. I can tie it or not. I can add from provider. I can come over here and say, okay, from Inventor, I want to add, this hot rolled stainless. Okay. It brings it in. I can set a nesting color. I can change this. Call it whatever I want. And once again, when it is working properly, Inventor Nesting will look at the material and the thickness and match them. If I bring in a part that has that material and that thickness, it will map it correctly. And in 2020, at the moment, that's not working. And I'll show you the implications of that. Another thing about materials. Notice I've got packaging over here. Notice materials and packaging. If I go to packaging, the default package that Nesting puts in is a 48 by 96 sheet. Excuse me a minute.
So, Walt, with those, we've got a couple of different things there. We've got the materials that are already in there and listed, and those are specific to this, right? They're specific to the nesting tool. And then we've got the other tools that we can just load in. Excuse me, not tools, the other steel shapes, steel sizes that we can just load in. So
am I back on?
The library is here, and we can import from Inventor as well, correct?
Sorry, I lost audio for a second. I apologize for that.
No worries. I was just, hey,
the line dropped.
No problem. I was talking about the idea that we have a couple of things going on here. We've got the standard ones that are loaded in, and those are part of the nesting tool. And then we've got ones we can import from Inventor as well. So there's a library that we can work with as well as the ones we import from Inventor, correct?
Well, if I pull up a generic this template here, standard inch, this one is the one that loads up stock. And if I come into this guy, there is actually, it'll come in just with one generic in here. So you have to add materials, whether you add them from a provider, from Inventor, or just add them generically. You have to add materials to it. And so you need to build up your library of materials that you are actually using. And let's go back and go back to this guy here. So once you have your materials in, you can also set your packaging. And notice, for 3/16 steel, I've got a 4x4 sheet and a 4x8 sheet. And if I look at these and pick on these, the length, the width, it's either rectangular or from a roll. I can specify that this is coming off a roll if my CNC machine works that way. I can set a cost in here for the sheet, and it will do some fairly rudimentary costing, but it'll do it. And then if I come over here to the nesting tab, I've got left trim. I've got all this set at 0 now. And the other, I come back up here, packaging, nesting. Okay, select the material, go to the nesting tab, and I've got some options I can set for default on this thing. My material grain is 0 degrees. Orientation adjustments. Do I want to allow parts on this sheet to rotate 90, 180, or 270 as a general rule? Now, I can specify certain parts when I get to actually importing parts. But as a general rule, maybe this material I'm using has a grain, and I don't want to allow it to rotate 90 or 180. I can uncheck those. I can set a deviation on this. I say, okay, so only allow 170. Add a deviation of 5 or 8 degrees, something like that. It can rotate it just a little bit, and I can set the increment for the degrees if I should want to. Some minor settings here: frame width and item separation. You know, how far apart do I want these? Is the sheet double-sided? I'm going to go ahead and leave all this checked. Once I've got my packaging done, it's time to actually import some parts. And so what I'm going to do is I'm going to come over here and go to Sources. This allows me to select the sources, and I'm going to click on Source Files, and I'm going to find that Burn Table Main, the top level assembly for this guy. Say Open. Now, here's where the bug comes in, because Inventor is not finding and mapping the materials. It's going to tell me it's going to make the 3 materials, 1/8" steel, 10 gauge, and 3/8 steel. It needs to make them because it can't map them. That's a bug. It should work, and it's not working. So I'm just going to say yes and let it create new materials. And it's going to think about this for a minute, and it's going to do an extraction process. And it's going to find all those parts. Now, notice it's going down this list and finding the parts and extracting them from the assembly. Because of the settings that I set earlier, it is only going to find sheet metal parts. It's not going to find the parts that aren't designated as sheet metal. However, it will actually bring in the assemblies because I can't uncheck that button. And so what I can do, once I get 100% down here, I'm going to come over here and sort the source provider. I'm not really going to need to see the assemblies, so I'm going to click these assemblies and delete them. Those are all the sub-assemblies in my top-level assembly. So now this is a list of the parts that I'm going to nest. And I'm going to just go ahead and say OK. And what the nesting utility will do is it will bring them in, and it's going to line them up in a row. It's not filtering on material sizes or anything like that. It's just lining everything up in a row. Before I do anything there, let's go ahead and take a look at the process material library. And I found out that it created 3 materials that duplicate some of the materials that I've got up here, the 10 gauge steel, the 3/8 steel, the 1/8" steel. Now that this is created, if I bring in subsequent pieces, Inventor will find them and map them to these 3. But again, this is a bug. I'm expecting it to be fixed. And this is one of the workarounds. Just let Inventor create the materials. I can come in here and delete these guys and rename these guys if I want. I can come over here and let's go here to 1/8 steel. And I'm just going to delete the one that I created. And then I'm going to go over to this one here. Call it 1/8" steel. Okay. So one of the ways to handle this bug until it's fixed is to just let Inventor create the materials. Don't pre-create them. Don't set them up beforehand. If I look at the packaging for this guy, it's done the default 96x48, and I'm just going to go ahead and work with that one for now. If I wanted to, I can add, go over here to packaging, right-click here, and I can duplicate it. Can come in here and make this 48 inches. Oops. And there it is, 96x48, 48x48. And I can come in here and rename these guys then. if I should want to. Once they fix that bug, you'll be able to create libraries of materials and packaging that are what you guys use, and they will be in the template, and you won't have to worry about this much anymore, at least not when you're importing from Inventor. I'm just going to go ahead and say OK. And so now we're back to this point here. And again, it takes all the parts and lines them up. And this is an opportunity to just take a look at things. I'm going to scroll down this list and just look at these guys and make sure everything looks as it should. Oh, what is that? If I select on it, it will, I can find it in the browser over here. I can click on here and open. That doesn't look right. Oh, it's not right. Okay. So I got a part that was inadvertently created as a sheet metal part that's not a sheet metal part. So I'm going to go over here to my environments, convert this guy to a standard part, and save him. And then I'm going to come in here, find this guy, source file, and just delete him. And that part is taken out of the nest. So this is kind of just a sanity check. Make sure everything looks like it's supposed to. And that looks pretty good. Now, if I go into nesting properties, this lists all the files that I'm nesting and the properties. Now, because I imported an assembly, the material and the source quantity are being controlled by the assembly, and I can't change them here. We're going to see in a little bit when I import some other files that, files that are imported from other places like a DXF, I'm going to have to set the quantity in the material because the DXF doesn't have that information attached to it necessarily. And so these will be editable in other cases. In this case, everything's coming from this assembly so that they're not. I can mirror the part. I can set an orientation if I should want to. And I've got this bind here, which, the project has certain defaults that I showed you earlier when I set it up for what is allowed and what is not allowed. And so if I unbind this, I can, for individual parts, I can check and say, okay, this part here, don't rotate this a certain way. Don't rotate it 180 degrees or 90 degrees. And I can set individual deviations and increments off of this. I'm going to leave everything default for the moment. And I'm going to come over here and in the nesting study, I'm going to create a nesting study. Before I do, though, I'm going to wrap this browser up. I'm going to go create. And it's going to create a nesting study. Job quantity, I'm going to create, I'm going to build one of these. 39 shapes selected. I can go in here and individually uncheck them if I want to. Available packaging, I'm going to just leave as the defaults. It's going to go with 96 by 48 for just about everything, I think. Yep. Which is what I want. I can set some priorities down here. Desired yield, 80%. Remnant optimization, can't talk. Length and width or length times width. So I can tell Inventor what I want, how I want it to nest this. And I'm just going to say OK. And it's going to run through this. And if I pull this up again, there's 3 different materials in here, so it's going to give me 3 different results. There's 1/8" steel, 3/8 steel, and 8 gauge. And 2 of them have run already. They're very quick. The 8 gauge has got a lot more parts, so it's going to take a little bit longer. But it should be done here in just a moment. There it goes. Okay, and it creates my nesting study. Looking on here, you can see how it's distributed these parts. It hasn't actually placed any parts inside other parts. For instance, this space in here, if there was a part that fit in there, but it will do that. I've seen it do that in the past. It didn't do it in this particular study. And then I've got these 4 feet, coming off of the 3/8 plate, nothing else there, and my 1/8" pieces. Now that I've created this study, looking at this, these corner pieces that are kind of the foundation of the thing, they're sitting sideways to the grain, and I'm not sure that I like that. So I'm going to go back into my nesting properties, and those are these 2 pieces right here, FR1A and 1B, and I'm going to unbind them, and I'm going to uncheck the 90 and 270. So it can rotate in 180 if it wants to, but I'm going to uncheck 90 and 270 and say OK. And then I'm going to run another nesting study. This one's going to be nesting study 2. I can give it a name and a comment if I should want to. Say OK. So one of the things I can do with this is I can play with the parameters and play with the different settings, and I can create as many nesting studies as I want. And I can mess with it until I get what I like. We'll give this just a moment to finish up. And there it goes. Okay, and it found a way to rearrange the parts using really no more material, just a little bit more material, but I like that a lot better. Those parts are going to be healthier if they're with the grain. And so I've got a kind of a report here, nest name, nesting efficiency. It hit 77.5%. 3 sheets. The sheet cost was set at 1, so it's showing a total nest cost of 3. If I look at this guy over here, its efficiency was just a little bit better, but not worth worrying about. So I've got my sheets now. And again, as many nesting studies as I want to run, I can come up here and say, okay, I really like this one, which means I can right-click on this guy and delete him if I want to, or just turn him invisible. I don't want to see him for the moment. This is the one that I'm concentrating on. Now that I've got this, what I can do is I can come down here and I can pick these sheets, right-click, and I have 2 options for exporting them. I can export, send them out to a DXF, and I've got a configuration file that gets involved in that. The other thing that I can do with this is I can create a 3D model out of it. I'm going to go ahead and create a multi-body part file, include the stock, and say OK. And this will actually throw me back into Inventor. And I can use this for jigging purposes or anything else that I might want a 3D model for. I don't actually have AutoCAD running at the moment, but I should have done that. So let's get AutoCAD running. And I can open up that DXF file and show it to you. But from the nesting study, I can export individual sheets. And again, my options are DXF or a 3D model Inventor part file. So if I open that guy now, I think he went into test, yes. This is what I get in AutoCAD. And I've basically got 3 layers here. Oops. Layer 1 is going to be all the shapes. Layer 251 is the standard layer that it puts all the text on. But that's the output. Okay. That is, generally speaking, a lot of the functionality, a straight through look at, going from an Inventor model into a, into a nest and export to DXF. It's really pretty straightforward. There's a few little things along the way, but I found, bugs aside, it works pretty good if you can get around the bugs. If I bring in a DXF, I'm going to go back up to my geometry sources here. Let's go ahead and just, I'm going to turn visibility off on this nesting study. Leave that up. I'm going to go back to my sources. And for source files, I'm going to pull in this DXF file. Now this DXF just going to bring that guy in. One of the things about DXF files is if I come back here and let me find that guy where yeah, there he is, cross brace left. Okay. So this is the sheet metal part that one was built off of. If I go to my flat pattern, and I right-click over here and save copy as. And it's already created one, so I'm going to go cross space left -02 and hit save. Now I've configured these VFX options. Whoops. To export the bend lines as well as the inner and outer profile. Those are the layers that are going to come out visible. Front and back bend lines, the inner and outer profile. And so if you notice, when this comes into the nesting utility, it comes in with the bend lines drawn on there. This can be useful for etching. This is if you need to do etching or want to etch the bend lines on or some other things like that onto the pattern. Currently, there's no way that I know of to do that with the straight Inventor files. But if I go out to DXF first, I can bring the bend lines in with the DXF. The other thing about the DXF is it will not try to map this. And so I can come in here to my sources, or excuse me, my nesting properties, and find that DXF file. And I can set this to any of the options that I want. Maybe it's 3/16 steel. And I can set my quantity. Of course, I have to set my quantity because the software doesn't know how many of these I'm making. So I'm going to make 4 of them. I'm going to make it out of 3/16 steel, which actually let me, I wouldn't do this, but let's go ahead and set this at the material Yeah, okay, I'm going to set it at the material ID 14, or 11, which was the 3/8 steel. So we'll add it to that one. And that's way too thick for that particular part, but just for the sake of the illustration. And the rest of this I can accept the defaults on and say OK. So a DXF file coming in is going to be handled just a little bit differently. And individual parts coming in that are not part of an assembly will also be handled a little bit differently. If I were to go into my sources here and bring in, actually what I want is, let me grab that sheet metal part. Hang on a second. Cross brace left. Okay, it's not gonna map it. I can say yes. So it found that guy in there. Say OK. And it will bring the individual part in. And once again, I go back to nesting properties, and the material is being controlled by the part, but the quantity I'm going to have to set myself. I don't really want that guy in there. He wasn't set up for this, so I'm going to go ahead and find him. And delete him. Okay, as far as importing other types of parts, and I'm going to burn in a lot of time here, so I'm going to go through this really quickly, but I'm going to talk about how the nesting utility will bring in parts that are not sheet metal parts. So I've got a part over here. This is not a sheet metal part, it's just a regular Inventor part. Now, if you bring in a regular Inventor part, there's 3 ways that you can specify to the nesting utility what to use for a profile. I have got a sketch on this guy. I basically just threw a sketch on this surface, projected all the edges, and if the last thing in the browser is a visible sketch, when I bring this into the nesting utility will use that sketch, and so that is the profile that I will get. If, on the other hand, I've got another version of this part, there's no sketch in here. It's not a sheet metal part, it's just a regular Inventor part. In that case, the nesting utility will use the first extrusion. So what I'm going to get is I'm going to get this thing without the 2 holes, because that first, if I wrap this guy up, it's going to get that surface right there. Okay. So with this part over here, the link sketch, I'm going to get the profile with the 2 holes. With the link extrusion, I'm just going to get that first extrusion. For this guy right here, this is another regular Inventor part. But what I've done is, for this extrusion 4, I went ahead and did the sketch. If I edit the sketch, I projected all the edges. I just did a project cut edges on this guy to get this guy. And so that sketch contains the entire profile. And I'm going to right-click on that sketch right here and say Use for Nesting. And now, with that checked, when I nest this part, it's going to bring in that sketch. So for a part that is not a sheet metal part, 3 ways you can bring it in. It will either bring in the first extrusion, whatever that is. it will bring in either a sketch or an extrusion. I can use an extrusion for nesting as well. The sketch or the extrusion that I specify, or a sketch, visible sketch that is the last thing in the browser. So one of those three. And just to show you how that works, if I go to this guy, blank file, I'm going to go Sources and Source Files and go into my test folder where all this is. And I've got the fish paper. I'm going to shift select the link extrusion and the link sketch. And I'm going to let it map materials. That's fine. And it does the extraction, and if I bring them in, that was unexpected. Why did I change that? I might have changed it. Hang on a second. Let's go back over here. Do I have that one checked? No. That worked earlier. I've got a feeling I did something wrong here, but I can't think of what.
It worked earlier is something I say in every demo I've ever done in my entire life.
We do run through these, yes.
All the time.
Okay. Well, that should have brought the sketch in. I don't think we really have time to troubleshoot it. But, and again, one of the things about this, if I go back to my providers, oh yeah, okay, all four of those are checked. Yeah. If I, just to show you, if I do this, let's go ahead and start a new nest here. And I have all my IPT providers checked. Say OK. And I'm going to bring in that CNC burn table again. It's going to bring in all of the parts. Whether they're sheet metal parts or not, it's going to try to find a way to nest them using the criteria that I just explained to you. And so I've got some parts in here that are generic CAD parts. It can't really figure out what they are. I'm just going to say no and not map those. It's going to go through the extraction process here. But it's going to find everything. And so the takeaway from that is you want to set your options before you do the nest. I can come back in and delete the stuff that I don't want, but it's already, if I told it to map materials, it's already mapped materials, and I'll have to go back and delete those as well. And so you want to make sure that you have your import settings set. If you just want sheet metal parts, I'm just bringing the sheet metal parts. If you just want a particular type of part, and this is going to take a little bit longer because, like I said, it's trying to bring in everything. Caleb, how are we doing? Do you have any?
We're doing good. We're getting close to time. Well, this runs. I've got a few questions that have come in that I'll just ask here real quick.
Okay.
Okay. So one of the questions was, can you move parts on nested sheets and fine-tune their placement?
No, not in the nesting file. The nest is going to give you what it gets. If you want to do that, the way to do that would be to go over here into AutoCAD once you've exported it to DXF. And I can move stuff here, if I want. I can move this geometry. This is all just regular AutoCAD geometry. So I can do a move from here.
Now, one thing you included you were working with that sketch. Can you include or isolate features and say, hey, I don't want these to show up in the nest? Can you mark those in the part before they go?
No, it will not let you mark specific features. You would need to create a sketch, and this one, Link Sketch. This seems to be the best way to do this, the most reliable way at this point. Create a sketch that just has the features that you wanted in it. So, you know, if I edit this sketch and come in here and grab that, you know, that circle there and make that one construction line. Okay, now if I nest this, I'm going to get this outer profile in this feature. So you would want to tweak it, create the sketch, make it visible, the last thing in the browser, and then add or project anything that you want.
Okay.
And that would be the way to do that.
Now, this has been doing all this nesting and putting all this together, but does it create any code or program from here that will go out to a laser, or is that a secondary operation of the laser?
That's the DXF file.
Okay,
and
so it's just the DXF file, and then that would be passed over to whatever software that's going to that.
Correct.
Okay. Couple of quick questions. I'm sorry, go ahead, Walt.
I do want to qualify that there is a way to take the output from nesting into HSM, and
there we go.
You know, and I have just seen that link. We've got a couple guys that are really sharp with HSM, and they know how that works. I've seen that. I haven't played with it much, but if you needed that kind of code, HSM would be the place to generate it.
Yeah. So if everyone doesn't know, HSM is the CAM tool that's part of the collection as well. So when you do that DXF, does it go? What layers does it put those things on? We've got a client that says, "How do I get the sheet DXF with all parts in the same 0 layer?" Our system requires all parts on the same layer, and mine always end up with multiple layers.
Okay, let's take a look at the configuration file. If I actually, let me think about that a minute. Drawing a blank on how to get to the configuration file options. Okay, in your options tab in export, there's a default export configuration, and if I come over here and edit this, I can come in and I can create a custom configuration. And this is where I specify, you know, nestable contours, what layer do I want them on. I can set that to put on layer 1. Etchbox etching data, what layer that goes on.
Perfect.
So line style, yeah. This is where
the layers for each of those, so that it does go out at 0. Okay. So that's within the options, and it's creating a new configuration file for that. Makes sense.
Yes.
Okay. So spacing between the parts. We're looking at configurations. Can we control the spacing between the parts?
Yeah, if I go to options, let's see. No, that is in process material library. Okay, going to 3/16, nesting, item separation. So you can do that per material.
Per sheet. Excellent. Okay. Cool.
Yep.
So we've got, let's see here, my questions, and we're getting close on time, guys, so we'll try and get to them all. If we don't, you can definitely email us, and we can follow up with something like that. John Tucker asked, is the product design and manufacturing collection an extra cost? I guess I don't know compared to what, John. So, yes, there is a specific cost for that. It is different than if you just purchased a seat of a printer. Of course, everything has to be now, so you could ask your sales rep about that. So I will, without knowing compared to what, I will say yes, it is more than a seat of Inventor, I guess. We'll go with that. Jackie Wagner said, what's the purpose of using Inventor Nest package since you can't write the program directly from it? Says I can take the DXF files and nest with the CAM software. Absolutely true. You definitely can do that, and it's another way of doing it. One of the benefits here is we get an IPT file that has the nest in the IPT, and we could then begin creating fixtures and jigs and things around that. So, of course, we could go the other way, create the nest in the other package and send it out. But if you don't have the CAM software, it's going to do the nesting automatically. We've got the nesting tool here, and then we can also create the jigs and fixtures for it because we have a solid file generated from there. That's been answered. We can't suppress a feature, so we cannot suppress a feature in Inventor to keep it from showing up in nesting. And I think we're getting close to the end.
However, you can create a sketch without that feature in it. So.
Yes, that can be exported. Okay.
One thing I will say about the purpose of the nesting software, the nesting utility as it stands now, and they're adding functionality, it's getting more powerful, but this isn't designed to compete with the high-end nesting packages that will do things like inventory management and remnant management and integrate with other things. This is designed for, one, for companies that don't have that kind of software, that don't use the large nesting packages. And another thing, just for an engineer to be able to do a quick nest and get an idea of how much material he's using on a particular project. This is something, maybe I can feed this out to my, powerhouse nesting package when we're ready to go to production. But if that's a big, if that's a big step to do, I can do a quick nest right here in Inventor and find out, okay, I'm using about this much material. Here's about what this is going to be, and play with my iterations at the design level without having to go outside of Inventor to do it.
Very good. So Jeff Smith had several questions that were around remnant sheets, fall-offs, partials, prioritizing for different sizes of sheets. And Walt, I really think you just kind of answered those. This is not a tool that accounts for that or takes care of that. It is really to get that first pass sort of thing, to get that kind of different information in there. Another question that he had that I'm kind of curious about myself, can you manually add parts as extras, or would that be done at on the DXF side over in AutoCAD?
No, if I come in here to this nest here and go to sources, I can add, I can combine any group of parts together. I can come in here and add, let's go back here to test, and that warped part.
So we can add another part in there.
Yep.
Okay.
It will be happy to attack that, and it just tacks it right onto the end there.
Awesome. Okay, so what about common line cutting? Joshua Martinez had a question about, can you nest for common line cutting?
Common line cutting.
Yeah, so it's a single pass. The parts share a single edge of the lasers. It would go by and cut that. I assume it would be basically a nesting at depth 0. Those parts would be right against each other. Can we set that to 0, or again, would that have to be done in the DXF file?
I don't see any reason why you couldn't set the. Let's go in here and look at nesting. Item separation. You could set this to the width of whatever the laser is going to cut. I mean, very thin, obviously. I think. Can I just set that to 0? Yeah, it let me do it. I'd have to test that to see. Which one did I do? Let's go up here and do this one.
Okay, so yeah, either way we could set it to 0, or we could go ahead and, of course, it could be done over in the DXF file as well, right? We could put it right.
Yeah, tweak it there.
Yeah, so it's a couple of options.
I'd have to test that to see how well it actually worked, but I don't see any reason why it shouldn't.
Yep, I'd agree. All right. So we are right at the top of the hour. Looks like we've been able to get through the questions. Walt, thank you so much for taking us through all that. I appreciate it.
Awesome.
Gladys, I don't know if you have any other housekeeping things, but I think we're done for today.
Okay. If you have any other questions, feel free to send us an email, info@rand.com, or call us at 800-356-9050. We will send everyone that registered a video recording of this session. Again, we thank you for joining our session, spending an hour with us. Enjoy the remainder of your day.
Thanks, everyone.
Thanks, Caleb and Walt.
Thanks, everyone. Bye now.